Welcome to homework.
All right, we've been asked to consider the difference of the nitrogen in pyridine versus the nitrogen in pyrrole. Just draw this a little different. And specifically, we're asked why it is that the lone pair on nitrogen in pyridine is not included in the count of pi electrons for the system, whereas the lone pair on pyrrole is. Well, consider that this nitrogen is sp2 hybridized, right? We've got this double bond here and then a single bond. So the nitrogen is in fact participating in this pi system, right? Like it's got a p orbital, but its pi system is creating a double bond with carbon, which means this pi system just has this pi p orbital just has that one electron in it, just as every other p orbital has a single electron, right? And also recall that this nitrogen, because it's sp2 hybridized, is planar, right? So its lone pair, just like its bond up and to the left and its bonds up and to the right, the sigma bonds, its lone pair is in the plane of the page. So its lone pair is actually just kind of sticking out of the ring. There's no room for it in this p orbital because it's already got one electron from nitrogen and it's sharing that, with the neighboring carbons. So we can't put that lone pair in there. And it's planar, so the lone pairs have to go somewhere, which means the lone pairs have to be in the plane. Now let's contrast that with pyrrole. Now, in the case of pyrrole, we still have an sp2 hybridized nitrogen, even if it's not immediately obvious that it should be. But now we've got a hydrogen bond, or a bond, not a hydrogen bond, it's a bond to hydrogen, right? And so we can conceptualize the three bonds to nitrogen as being in a plane, right? Before we had to put a lone pair in a plane because there was no room in the p orbital. But now we've got this hydrogen, and that's one of the three bonds that will, sigma bonds that will be in the plane, which means that this p orbital can accept the two electrons from nitrogen, or can hold the two electrons from nitrogen. And for that reason, I guess contrast that with this case, we couldn't have nitrogen with a single electron planar, right? And then having the two electrons in the p orbital. Single electron planar isn't like a thing. I don't know if there's a better way to explain that. If we have our our sp um, two hybridized orbitals, we've got to, once we're done with the system of overlapping and whatnot with our neighboring atoms, we've got to have two electrons in them, in each of them. We can't just have a single, like a radical nitrogen, right? It would be incredibly unstable and not energetically favorable. Whereas in the case where we have a sigma bond to hydrogen, that's a place where nitrogen can put one electron, right? Because hydrogen's going to put an electron there. So there's going to be a total of two electrons in their overlapping S and sp3 hybridized orbital, sp2 hybridized orbital. For that reason, in pyrrole, the lone pair can go into the p orbital, which in fact makes the whole system aromatic, right? Because it's planar and it's got 6 electrons total in the pi system. Yeah, so the difference is really a planar lone pair versus a planar hydrogen. And the fact that the nitrogen has a double bond. So for that reason, uh, it can only really contribute one electron to a double bond, right? So that would be another reason the lone pair can't go in there, because that would overwhelm both carbon and nitrogen. They both have expanded octets, if that were the case. Yeah, so the only true option is for in pyridine. Oh, yeah, so the answer is one. The nitrogen pyridine is part of double bonds. So the p orbital is already filled and cannot accept more electrons. Sure, right? Because this p orbital is seeing an electron from nitrogen itself and from carbon. Whereas if you look at this case, this p orbital is not part of a double bond, right? It's not like a shared uh, one electron from nitrogen, one electron from carbon. There's no double bond there. Okay,